Yes, class. So, in the last class, we have completed with the resolution. We have completed with the parallelogram law. So, polar form and Cartesian form, both the forms have been completed. Now we have to go to towards the next topic, which is the resolution of vectors. So, when is the resolution of vectors needed? Resolution of vectors is needed whenever you have a quantity which is making some angle with one of the vectors, but it is not along the direction of your x or y axis. Then you require the resolution of vectors. For example, see, in many of the cases, we have to find out our resultant. And how do we find the resultant? We take all the quantities along x-axis, add it up, subtract it up, find the total resultant along the x-axis. Then we have the quantities along the y-axis. But if some of the quantities are present, suppose one quantity, this is some force. This force is 5 Newton, which is present in this axis. So there must be some angle. Let's say this angle is theta. So what we do, this is x-axis, this is y-axis. We split up this first vector that is present into its x and y component. Now we require its x and y component so that we can calculate the resultant along x and resultant along y. So how will we calculate? This one we will get forces component along x. Here we'll get forces component along y. So it is the process, see, definition is also written. It is the process of splitting up of vectors into its components acting in different directions. So these are basically fx and fy, these which have been obtained. These are called as the components. Now, for x, we have obtained fx. For y-axis, we will obtain the component of the force along y-axis. And these two terms, these are called components of the vector, means components of the main vector. Now we have rectangular components itself. Now, rectangular components I'll tell you, but before this, see. So now if you look at like this was a force which was present as 5 Newton. I'm repeating this. Fine. Force is there, 5 Newton. Now this is at some angle which is not defined. This is at a random angle. It is present at a random angle. And this angle is not defined. So what do? We split up its components. Now, what exactly is the meaning of rectangular components? Rectangular components means splitting along specifically x and y axis. If it is split along multiple axes, if it is split along different direction, different planes, then we just say it's the resolution of vectors. But if we say along x-axis, along y-axis, then we call it as the rectangular components. And there's a method to find out the values of fx and fy. Fine. Write down this introduction quickly, resolution of vectors. Then I'll discuss how to find out the rectangular components. Write it. Other students also, please open the videos. Jobita has only followed the instruction by herself this time. Jasleen, Shaima, Zainab. This is a rule for every class. Let us come to the class. Rectangular components means specifically you are splitting the main component or main vector into x and y axis only. Why rectangular? See, rectangular means something which is at 90 degree, and both the x and the y axis, they are situated at 90 degrees to each other. That's why we use the term rectangular for these. Now, how to resolve vectors, how to solve the vectors. See, these components, suppose we have a main vector. Let's say this is 7 Newton. Fine. So I have split it 7 Newton into 4 Newton and 3 Newton. So splitting has occurred, and I have split it into 3 Newton and 4 Newton. So basically the 7 Newton, this is now made up of 3 Newton and 4 Newton. But the condition here is that in different directions. Clear? So 7 Newton is made up of 4 Newton and 3 Newton, right? Or what you can do to get the exact value, you can take 5 here. It's better example. Let's take 5 Newton here. Suppose this 5 Newton is made up of 3 Newton and 4 Newton. I have changed the value so that you don't take it as 4 plus 3 is 7. That's why 4 and 3 and 7 were written. You can take any of the values. So 5 Newton is there. Now see, how have we obtained 5 Newton? Basically, 4 Newton and 3 Newton, they are situated at an angle of 90 degree to each other. Now this is a solution that I've already told you. How to actually resolve vectors, how to find out the vectors. So there's a method. Suppose this is a vector A. Theta is being made with x-axis. Now remember, with whichever axis theta is made, that axis receives cos component, cos theta. And the perpendicular to this component becomes sine theta. This is just the rule which you have to remember for solving all the questions. How to apply? A is present, and I have to find out the component of A along x-axis. So component of A along x-axis. This is A cos theta. Why? Because theta is made with the x-axis, A cos theta. And perpendicular to this means this one. This becomes A sine theta. Now, whatever value of A cos theta will be, I'll get it. Whatever will be the value of A sine theta, I'll get that. This is how you resolve the vectors. See carefully, class. Suppose this is the theta which is mentioned. What have I told you? The axis with which theta is made, that receives the cos component. So here the theta is made with the y-axis. So this becomes A. Suppose this is the vector that we have, A vector here we are having. So theta is being made here. So here when you multiply, this would be receiving the cos component. So this becomes A cos theta. And the perpendicular to it here, this component that we are having, the perpendicular to the A cos theta component, this one becomes A sine theta. So this is how you will be resolving. This is not with reference to some x-axis or y-axis. With whichever axis the theta is being made, that will be multiplied to cos theta, A vector or whatever vector, multiplied to cos theta with the axis with which angle is made. And perpendicular to it becomes then sine. This is how the resolution of vectors is done. Through this question, we will see how to resolve the vectors, but basic components, I hope you've understood. Write it down. See, now how to resolve? We have three vectors, F1, F2, and F3. F1 is 10 Newton, which is present. F1 is 10 Newton, F2 is 5 Newton, F3 is 2 Newtons. So when you have F1 as 10 Newton, the angle which is made with the x-axis, this is 30 degree. So see, just focus on F1 first. We look on the other rest of them later. Just focus on F1 first. F1 is equal to 10 Newton. This is made at 30 degree with the x-axis. Now see, I have told you that the angle which with which the axis with which the angle is made is taken as cos theta. So when you resolve F1, here you get its component F1, which is not F1, Fx actually, or the component of F1. Let's not write the name. Directly let's write the value because lots of components are present. So this will directly be F1 cos 30 degree. That you can solve further, 10 into root 3 by 2, which is equal to 5 root 3. Fine. And what about the other component? The other is perpendicular. This is the perpendicular, which is F1 sine 30 degree. So this is equal to 10 into half, which is equal to 5 Newton. Now look, 5 root 3 and 5 Newton. These are the two rectangular components of 10 Newton. Fine. Along x-axis also we have resolved. Along y-axis also we have resolved it. Now look here, F2. So again, theta 37 degree. This is made with this axis. So when you will resolve this one, F2, this will become F2 cos 37 degree. Fine. And what is the value of F2? F2 is 5 here. This is 4 by 5. So this will be 4 Newton. Fine. And then we have the perpendicular component. So here when we solve the perpendicular component, this will become F2 sine 37. This is equal to 5 into 3 by 5. So this is equal to 3 Newton. So you have 4 Newton, you have 3 Newton, which are the components of 5 Newton. See, everything is now along x and y axis. Do we need to solve this further? F3. See, F3 is already along the y axis. Y dash. This is already along the y axis. No need to resolve it. If this was making some angle, this was in some plane, then we had to resolve it. Now there is no need to resolve it. Now we have to find out the resultant. So how to find out the resultant? Look, we have, this is x, y, x prime, y prime, these axes. So along x axis, we have 5 root 3. Anything else? Along this axis, y axis, we have 5 Newton and we have 3 Newton. Look, two arrows are there, two forces are there, 5 Newton and 3 Newton. So here we have 5 Newton and here we have 3 Newton. Then here we have, which is the x prime, we just have 4 Newton, no other force. So this will be 4 Newton. Fine. And lastly, here along the negative y-axis, we have 2 Newton. So this is 2 Newton. Now look, we have resolved all the vectors and this is what we are getting. Now you have to find out the resultant component along x-axis and resultant component along the y-axis. Look here, when we are calculating the resultant component along x-axis, so these are in opposite direction, so they will get subtracted. 5 root 3 minus 4. We can solve this further. See, 1.73, 1.7532 is the value of this root 3 minus 4. So this would be around 2.66 minus 4. 5 point, no, this won't be 2.6. It would be more than that. Yes, class. I hope now the screen is visible. See, I was saying here when you have 5 into 1.732 we have. So this would be around 8.66 something, which I'm not sure. Just calculate this. So once you will solve, so final answer would be around 4.66 something, that you can calculate it precisely. 8.6 is okay. Then 8.66 minus 4, then we have 4.66. Correct then. And 4.66 is the right answer. Okay, then 4.66. Then along y-axis, so this is 8, 3 plus 5 when you add, this is 8. And 8 and 2 are in opposite direction. So 8 minus 2, this becomes 6. Now you have one force. Now this is still not the answer. This means force along Fy, now you know this is 2 Newton. And force along X, you know, which is 4.66 Newton. They have the angle 90 degree between them. Final resultant force would be calculated by under root 2 square plus 4.66 whole square. This would be your final answer. Then you will calculate tan beta to get the magnitude, which would be this 2 divided by not 2, 6. Okay, 6 Newton we have. No, house. We have subtracted 2, so this is 6 Newton. So this would be 6 divided by 4.66. And then your beta would be something tan inverse 6 by 4.6. So calculations part, I'm not going into the details. You should know how to solve all this. Basically, you know how to resolve the vectors, find out the values along y and x axis, find out fx, find out fy. Once you have fx and fy, then find out the resultant using your parallelogram. Is it clear to all of you how to resolve the vectors? Is there any doubt in this? Clear? Jobita, Jesleen, Shaima, Zainab, clear?
Yes, ma'am.
Okay, write it. Resultant part. Yes, Zainab. Look, see, when we are talking about the resultant part, we have separated the two components. Fx we have and Fy we have. Now we know the net total force along x-axis. We know the net total force along y-axis. That was our mission because we had forces that situated at random angle. Now that part is being solved. So what we have to do, once we have the component along y-axis, x-axis, we have calculated the result. Remember parallelogram law for 90-degree case, it is under root a square plus b square. This is only the thing which we are calculating. Now it's clear? How was your exam, Jobita?
It was good, ma'am.
Okay, do share your question paper with me, Jobita.
Okay, ma'am. I will send it after the class.
Now see resolution of vectors in 3 dimensions. So this is not very important. The important part was the above, which we have discussed, the rectangular components in 2 dimensions. That was the important part, most important part. Resolutions of vectors in 3D, this is part of your syllabus, so it can come, but this is not very important. So hardly the questions are asked on this, but since this is a part of your syllabus, questions can be asked. So you have to revise it in any ways. But if time is less for you for revision, specifically before the examination, you can avoid this topic at least. But since this is present in your syllabus, we'll be discussing this. Now see, rectangular components in 3 dimensions means now before this earlier we were just considering the x and y axis. Now we will be considering the z axis also. So alpha is the angle made with zx, y and z is beta, and x and z is gamma. So these are the three. Now once you have to resolve all the vectors, once you have all the vectors which are present. So ax, this is a cos alpha, ay is a cos beta, az is a cos gamma. Now there is no rule for this. This is as it is because the derivation part is there, which is not at all in your syllabus. So no need to go into the details. Fine. Just remember for the x component, whatever angle is made with the z, that is taken as alpha. So it becomes a cos alpha. Likewise, a cos beta, a cos gamma. Magnitude, how can you calculate? You have ax, ay, az. Just square all these terms. Square all these terms the way you have been calculating the normal Cartesian forms vectors magnitude. Remember resultant I have told you, square of I cap plus square of j cap plus square of k cap. Yes, that way. All right. And so see, if I write a x is equal to a cos alpha. So sometimes to find out the reverse values, to find out the values of these angles, what we can do, we can have this term getting divided in the denominator. So this becomes ax by a, cos beta becomes ay by a, cos gamma becomes az by a. Fine. Now class, this I will tell you here. So if we add all these, sometimes one question is asked that that only I'm going to discuss. It's a derivation, but it is asked in the form of a numerical type question in your exams. That I have seen in most of the question papers of the schools, especially in the finals and half yearlies, not in the unit test, because in the unit test you have lesser weightage. So school and the examiners will not focus on the rectangular components in 3D part rather than focus on the 2D part. But in your half yearly and especially in your annuals, you have plenty of syllabus present. And if the syllabi is more, you have more chances of getting these types of questions. So for that purpose, this is important. And I have seen this particular question, to prove what is this. Prove this. Prove what is this. Basically, prove what is this means. Prove that this is equal to 1. Or it is asked, calculate this like this. Fine. Prove means you have to show something. So in proof questions, 1 will be given. Now how? Cos alpha is ax by a, right? So this whole square plus this will become ay by a whole square, plus we have a z by a whole square. Fine. Now what we can do, we have a common denominator, which is a square. So this becomes ax square plus ay square plus az square. Screen is lagging. Okay, let us see. Now you have ax square plus ay square plus az square. So what is a equal to? Under root ax square plus ay square plus az square. This is how you calculate the magnitude of the vector A, right? I am solving that part, but before that, just focus here. Now class, if I square A, so the square root will be gone. So I'll be left with ax square plus ay square plus az square. Look, it means this entire term is equal to a square. So here, when we were solving this entire term, this is still equal to a square now. So this gets cancelled. You get the answer as 1. So the question usually comes, prove that cos square alpha plus cos square beta plus one more term you have gamma plus cos square gamma. This is equal to 1. So this, I have seen this question coming, and this can be asked to you in the exam. This is a little important to prove this. So derivation is very easy. Class, I'm repeating the steps. Look, the derivation is very easy. You have the rectangular components in 3 dimension like this. Ax is a cos alpha, ay is a cos beta, az is a cos gamma. Put the values of cos alpha, cos beta, cos gamma from this. Square it and add it. You will be stuck at this point. If magnitude of A is this, so when you square it, you will get this term as it is. That means this is A square. So when A square and A square get cancelled, you have 1. So this derivation, this can prove. Fine. Write down about the rectangular components. See, in the first part, we have to calculate the magnitude of the vector A. So when we are calculating the magnitude, I cap's coefficient, we square it, plus j cap's coefficient minus 3, we square it, plus k cap's coefficient 4, we square it. So this becomes 4 plus 9 plus 16. So 29. This is root 29. Now second, direction cosines. Direction cosines means the same. Cos alpha would be ax by magnitude of A. What is ax? Means the coefficient of I cap, it is 2. Divided by magnitude is root 29. Then we have cos beta. This is ay by a vector magnitude A of A. This is 3 minus 3, sorry, minus 3 by root 29. Lastly, we have cos gamma. This is az divided by the magnitude of the vector A. So this is 4 by root 29. This completes with resolution of vectors. Now we are just left with dot product and cross product. That requires one complete class. Write it first. Yes, it's necessary. It should be in modulus, because if you remove the modulus, that shows the complete vector without the magnitude. So modulus only defines that this is the magnitude, not just the vector. Vector A and just without the yes, these are the same thing, Shaima, because without that vector symbol, it means it is just the magnitude. It's a scalar quantity, and with the modulus also it becomes the magnitude. So you require this vector just for the vector and these modulus sign for the magnitude. Okay, this is the last topic from your vectors. Then we will be starting with angular projection and horizontal projection. Now, see, when you multiply, this is something which you have to remember. When you multiply vectors with a number, suppose a positive and a negative number. So when you are multiplying the vector with a number, it becomes n times plus n times that vector. And this becomes minus n times. For example, force of 2 Newton is multiplied to minus 2. It will become minus 4 Newton. Like this. So this is clear. When you multiply vector with a scalar, this also becomes n times. Like this only. Fine. If you have a vector quantity, let's say you have velocity which is 3 meter per second. And I am multiplying it with some scalar quantity, let's say power, which is 3 watt. So when I am multiplying power and velocity, both will just become 9, right? You will be multiplying it. But when you multiply vector with a vector, then you have dot product, which is known as the scalar product, and this gives the scalar quantity. And vector with vector gives cross product, that is vector quantity. Now we have to discuss this section. This you already know. This you already know. You just have to multiply here. This is something very important which we'll be studying. First, make this table.